Hey there, folks. In this video, we're going to talk about the Pythagorean theorem. Okay, this is a theorem that most of you learned in middle school. Most of you probably feel pretty accomplished with, and that's great. Okay, today we're going to get a little bit more formal with it, and we're going to use it to find distance between 2 points, and also to potentially find some application problems and use it with that. So what exactly does the Pythagorean theorem say? All right. Some of you probably think it says a squared plus b squared equals c squared, but that is not what the Pythagorean theorem says. Okay, the Pythagorean theorem says the square of the length of the hypotenuse of a right triangle, put the little square in the corner there, makes it a right triangle, 90-degree angle, is equal to the sum of the squares of the lengths of the legs. Okay? So what a lot of teachers just boil that down to is a squared plus b squared equals c squared. However, we're going to be much more formal with it, and we're going to say that the legs are a and b, and c is the hypotenuse. Now, let's be forthright. It does not matter which of these two is A and which of them is B. However, this must be C. Every time, the side opposite the right angle. Okay? So, where does this come from, you might ask? Well, this all comes down to area. Okay? How do you find the area of a square? Length times width, right? But in a square, the side lengths are the same. So if one side is A and the other side is A, length times width then would be A times A, or A squared. Well, I happen to have that situation modeled right here. Okay? And so I have the area of this square here, which is A. So this would be A squared. This would be B squared. And this right here is C. Now what I'm going to do is I'm going to take A and I'm going to break it apart. Okay? Now I'm also going to take B. I'm going to move it off to the side here. And what I'm going to do is I'm going to take each of these pieces of A and I'm going to turn them over. Okay? I'm just going to put the hypotenuse along the outside of the square of C. Okay? Just hypotenuse, and I'm going to be very, very careful with that. Okay? Now when I do this, okay, it leaves a gap right here in the middle, which you may not be able to see all that well. However, this little square for B fits perfectly right inside that opening. So that's where it comes from. Okay, we've just demonstrated the Pythagorean theorem using areas. Okay, so it's not just something that somebody made up. Okay, an old ancient Greek guy and his friends actually found that formula. All right, so what I want you to do is turn to the page in your packet that looks like this. It says distance on a map using the coordinate plane. Okay, so we're going to keep this really simple here. Okay, now I know I never liked it when the teacher did the first problem because let's face it, the first problem is always one of the easiest. So I'm going to do one that's a little bit more difficult. Many of these are not going to work out to be perfectly nice square roots. Now, before we do anything, I just want to review how to find that on the calculator. So here's my calculator. I turn it on. There's some work from another video. To make the square root appear, you got to hit second and this little x squared button over here. That makes the square root appear. Then I'm just going to type in a number. So if they want us to find the square root of 36, I can type that in and hit enter. It gives me a whole number of 6. No problem. Okay? But there are some problems where we don't know the square root. So for instance, say 35. Okay? When you get an answer like that, we're just going to round it to either 1 or 2 decimal places. If the paper doesn't give instructions, I'm preferential to 2 decimal places, but do whatever your teacher asks of you. Okay, so let's clear this out, and let's get going. I'm looking right here at number 4. They want us to find the distance between each of the following landmarks. So they want us to find the museum. Okay, the museum is down here. And to find out how far is it to the grocery store. The grocery store is right up here. So all I'm going to do is I'm going to draw the distance to each. Okay? Now, what we want to know is not how far is it left and then up or down and then right. We want to know actually how far is it directly. Okay? We want to know exactly how far is that directly. Well, I can count here. Remember, do not count the number or the point that you start on. So, this is 1, 2, 3, 4. Okay? So that is 4 spaces. Okay? You may not want to draw on your paper for future problems, but because my grid lines aren't showing up for the video, I went ahead and drew these in. So now I'm going to draw straight down here, or count straight down. That's 0 because I haven't counted it all. 1, 2, 3, 4, 5, 6, 7. That side there is 7 units long. So, time to use Pythagorean theorem to find out how far it is from the museum to the grocery store. So, a squared plus b squared equals c squared. So, 4 squared plus 7 squared equals c squared. Okay? So I go to the calculator. 4 squared is 16. 7 squared is 49. So 16 plus 49 is 65. Now, be cautious. Many people stop right here, okay? But we don't want to know what c squared is. We want to know what c is, okay? So, c is, I have to undo squaring. So, c is the square root of both sides here. So, c is the square root of 65. And I don't know what that is. So, second, x squared, we'll make the square root appear, and then 65. Hit enter, and it says it's 8.06. So you could either say 8.1 or 8.06, and 6 would be appropriate because the next number over is a 2. Okay? The rest of those, you can go ahead and work on those, get some practice in, and get those checked off before starting the next video.